What'd you get on 70?
I got a picture. Hold on, I got a picture of
I
it.
think it was 8 meters per second squared.
No.
Oh, 70?
70.
Did we do that?
I don't.
This is my notebook from last year. So I got 1.1936 meters per second squared.
I think we attempted it.
Number
but
70.
we didn't get it.
We only got through one problem.
Yeah, we only did one.
There was one problem a day.
Yeah.
I thought we done 71 Friday and Monday.
Oh, I wasn't
Yeah.
here Friday, so.
We started
70 was Monday.
but we didn't grasp how to do it.
71. Wait. 70 was Friday. 71 was Monday.
Then I got the answers for 71.
Yeah, 71.
Okay,
we did.
71. I thought because I came in yesterday and I thought you guys were getting it.
Yeah.
Yeah.
Yeah, and then there was a
Yeah,
little
that's all the answers we got.
Yep, we're pretty spot.
So you got 8 meters per second squared,
Uh-huh.
and then for the force you got negative 10 newtons. Or you could have 10 newtons. It depends on how it was, which direction was positive and negative. And then for the coefficient of kinetic friction,
0.2039.
get in it.
Wow!
So you got 0.2039.
Did you not read my text? I told you that I had a doctor's appointment.
What text?
I texted you and said, I have a doctor's appointment. I won't be there. Please video.
Luke, can you airdrop that picture to me?
Yeah.
Thank you.
So, you guys doing pretty good?
No.
No.
Wow.
This problem was solved by like 2 people. The rest of us are clueless.
Yeah.
Okay. Alright. Guess I ain't getting out of doing it.
Sorry.
Getting out of doing what?
It's a problem.
Did I write that? Looks like I could write.
See? Golly. Spare no souls. Okay.
We're starting off good today.
Yeah.
Doing a pop quiz.
I'm feeling, I don't know any of this.
I'm feeling,
especially if you two don't quit.
What? What'd you say?
One more.
The one more? Is it one more after the one more, or is it
Oh,
one
no.
more?
Next one it's sent.
I think there's 19 now.
What?
That's
Y'all are
crazy.
weird. What
Who's
are
talking?
weird?
Let me go.
Ooh.
So if you can make it back from your doctor's appointment early.
Well, can I go to my doctor's appointment now?
Nope.
Wow.
Number 70.
Busy day. Then she got an eye appointment.
Alright, so we have a 225 kilogram crate. So we have a mass. 225 kilograms.
Nice.
It is pushed horizontally with a force of 712 newtons in free body diagram.
Fancy.
So we'll pushed. So force pushed is equal to 710 newtons. Its coefficient of friction is 0.20. So I have a coefficient of friction 0.20. Calculate the acceleration of the crate. So in this case, this is all the information it gave me here. So now we're going to start pulling for what we can pull, the information we can pull from it. Focus on your free body diagram first. So what other forces are acting here?
Normal force, force of gravity, force of kinetic friction.
Okay, so we got the normal force, which is perpendicular to the surface, right?
Yeah.
We can calculate.
Okay, what is the normal force equal to?
Negative.
The opposite of the force of gravity.
In this case, it is the opposite of force of gravity because force of gravity, where it's sitting on a flat surface, is just straight down.
off the tree stuff. It
No.
holds them on the flat stuff.
So what's force of gravity equal to?
225 kilograms times 9.81 meters per second squared.
Which is mass times gravity, so 225 kilograms times 9.81
So
meters per second
force of
squared.
gravity wouldn't be negative on this one? Or it would be negative?
You can make it negative.
Okay.
It is
I'm
negative.
showing the direction on it, so makes you feel better. We'll put that negative in there as acceleration, so whenever we do it. Ah, come on, man. So I get negative 2,207.25 newtons. Why does that matter that we have that? Because we need this information here. Because this now tells me that the normal force is equal to 2,207.25 newtons.
Fancy.
But it'd be the opposite, so it wouldn't be negative?
It's going to be positive, because it's opposite force of gravity. Now, is that all forces acting?
No,
Yeah.
What else is acting?
the force of kinetic friction.
Force of kinetic friction. How do you know it's kinetic friction?
Because it has the nu. Or it has the K, which means kinetic.
Because you said so.
I didn't say it was kinetic.
Because,
That's what we're like.
It's horizontal.
anytime there's a surface, there's going to be some sort of friction.
Yeah, but it can be static and kinetic. There's a key to whether it's static or kinetic.
The
Max.
force.
Is there acceleration? No.
The
Is it
force
what's
of
pushed?
gravity. Has it got anything to do with it? If
Yeah,
gravity's
push.
normal, then it's kinetic friction. Or
Being
gravity.
pushed, but what's the push leading to?
Force.
Trying to solve for
Acceleration.
acceleration. Where do you get
Movement.
acceleration in?
Force.
Mass.
Force
Gravity.
equals mass times acceleration.
Force applied.
We get acceleration from motion. So that means the crate has to be moving.
Oh, I
Since the
remember
crate is moving, it is kinetic.
But if it's still, then it's static. Right?
Yes.
Okay.
So, force of K, force of kinetic friction.
My physics book.
How is
That
it? Do we find
is it-
that?
Yeah, how do we find the...
And then,
How do you find it?
It says, but it's already given us the point 20.
What's point 20? What is that?
The mean.
the coefficient.
Which is? You're saying.
Coefficient of friction.
Coefficient of friction, and the formula for the force of friction is equal to the coefficient of friction times the normal force.
Here in a minute, can we do a problem where it doesn't give you the coefficient of friction, to where you have to find it in
Oh, praise the Lord.
That's a deal, Leo.
tech day?
Speaking of which, I did need a tech day eventually. Because I can't pull up PDFs on my laptop.
Chromebook? I
Yeah.
don't know if you can pull up PDFs on.
No, you can't.
I've got one put up.
Yeah.
That's a problem.
Yeah.
We'll figure it out.
Okay.
Okay, so in this, we need to figure this out. So we're going to find force kinetic friction,
So that
which is equal to 0.20. Ask your question.
So you multiply the normal force. What if it doesn't give you the coefficient? How would you find that?
Then you'll have to solve for it. If I don't give you the coefficient, either you'll have a chart, like some books have a chart to where you can look this stuff up. Like when I was in college, my physics book had a chart and had values in it that we would pull for. Here, they've made it just simpler. They're just giving it to you. That's kind of how I flow. If I don't give it to you, I'm going to have you solve for it.
How would we solve for it? Like, what's the equation for it?
So you're going to have to figure out what the force of friction is and the normal force.
Okay.
So
And you
that's-
find force of friction by,
yeah.
it's the opposite of force applied, isn't it?
Yes.
Okay.
So we get 441.45 newtons. Now here's the thing. we gotta make some decisions. We already said that up is positive.
Correct.
In this case, I'm gonna make to the right positive.
Yes.
I'm gonna stay with the normal thing. But this is where you have to understand directions and how your forces are working. Because force of friction goes to the left. So, it's negative. You can say, but Mr. Hardy, math is not so good. I know it doesn't, but I know the direction. I chose to the right's positive. So that means to the left has to be negative, yes.
When you're finding the coefficient of kinetic friction, that's the one where you don't have any variables, right?
You don't
Or
have any
any-
units.
Any units, no units.
Okay, so in this case, since we were given the coefficient, we have units.
Yes,
Okay.
because I'm finding a force.
Okay.
Mathematically, no units here, Newton's there, so no units times Newtons equals Newtons.
Units.
Okay, so now that we have that, we have to find acceleration. So I can look at you and tell you, in the y direction, we're not accelerating, but in the x direction, we are. How we know this is because whenever you look at this, look at what the net force in the x direction is.
It would be,
Be the force of kinetic friction plus the force being pushed, which is negative 441.45 newtons plus 710 newtons.
268.55.
so it would be moving forward.
Yeah, we know it's moving.
Okay, we just don't know how much.
268.55 is what you got?
Yeah.
Okay, so that's the force, the net force in that x direction. So that's the net force going on. How are we going to find acceleration?
Force equals mass times acceleration.
Very nice.
Because we have
So in
force
this
and
we
mass.
can now flip to the orange.
That was.
Force equals mass times acceleration.
How difficult of a problem is this?
I don't think it's very difficult.
Huh?
I don't think it's difficult.
I don't either, that's why I'm hoping this is as hard as it comes, right?
No, we still have to put it on a ramp.
Hey, no, we don't have to do that.
So 268.55 newtons divided by 225 kilograms.
So acceleration equals force divided by mass, which is equal to, that's a net force that we're looking at here, by the way.
In the X direction.
268.55 newtons divided by 225 kilograms.
Why would you use that for the net force?
Because that's what's actually acting in the
So
x
you'll
direction.
always use the net force to find.
When you're trying to look and see what's acting, what's happening, you're trying to measure values, yes. So I get 1.1936 meters per second squared.
Yep.
Buddy.
Questions?
The degrees thing. That was the
Doesn't
same.
apply here.
Okay, was that the same like section as this?
Yeah,
Oh, Lord.
same chapter.
I done forgot all that.
That degrees is just direction. That's all
That's
that
only
is.
when we're using like sine, cosine, tangent.
When you're coming off at angles and stuff.
I think that one's harder to do than this one.
That's because we didn't put it on ramp.
Let's
Oh,
not.
as of.
Any questions here on 70?
I hope that didn't.
I really hope
Probably.
it did.
We might want to stop the video. I don't think it hurt.
I don't think it would have, but.
That was
Nah, he'll be
It
alright.
wasn't bad.
Number 71. Alright, so force of 40 newtons accelerates a 5 kilogram block at 6.0 meters per second squared along a horizontal surface. So we have a force applied, so equals 40 newtons. We have a mass of 5 kilograms and an acceleration of 6.0 meters per second squared.
that?
The information from the problem.
No, something was.
Oh, it's them on top still. Okay,
Hey, let's go have a field trip on top of the roof and drop a ball and do physics.
oh my gosh, this is a great idea. No.
Why?
So,
Hey,
Arnett,
we did that and it was physics.
Can we go ahead and find the force?
You know, Maddie.
in this, let's go step by step. So, A, what would the block's acceleration be if the surface were frictionless? So there's not a force of friction acting here. So in that case, since we're saying there is no force of friction, means the only thing going in the X direction is what?
The force applied.
Our force applied. So that's really acting as our net force in the X direction in part A. So that's 40 newtons. Force equals mass times acceleration. Acceleration equals force divided by mass. Therefore, 40 newtons divided by 5 kilograms.
Why are you even doing
I can
this?
tell you now, this is not how we did this yesterday. So I do not know how we ended up with our answer.
40 divided by 5?
I think we took 5 times 6, and then
Yeah.
we subtracted 40 from that and got 10, and then we divided that by something, and then we times that by 5.
Yeah, we took them a long way around.
Sure. No, we did that.
Oh, I'm not writing anything down. Write that down one more time.
What do you like?
Hold on, I got a picture of it.
Yeah, she took a picture.
Oh, we got
We
that
took
because we took the
6 meters, 6 meters per second times 5 kilograms equals 30 newtons.
No, that's for B. That's
Oh.
how we got B. Yeah, that's how we got B.
What did A say again? What did the problem say?
Frictionless surface. What would the acceleration
The 6
be?
meters per second was with the yeah, we did that right. We did that perfect.
Was that like the whole problem?
For A?
We took I don't
Part
know.
A, that's it.
On here it says we took 6 meters per second times 5 kilograms.
That was for
equals
B.
30 newtons, but then under it said 8 meters per second squared minus 6 meters per second squared equals 2 meters
I
per
don't know
second
why we
squared.
did
Why
that.
are you?
Are you
And then-
trying to find, hold on, B, how large is kinetic friction force?
That's what it was for.
You guys went a long way around finding that.
Mr. R,
But we
why did you
got it.
use that?
There
Why
we-
did you use that to find zero friction?
Because
I didn't use it to find zero friction.
What's-
It asked me what would the acceleration of the block be if the surface was frictionless.
we found the net force where there's no friction acting on the opposite of the force applied, which would be the 40 newtons. So to only do it for the net force, you take those over, and the only one that was there is the 40 newtons. So there wasn't anything acting on that side of it.
Alright, on B, how large is the kinetic friction force? Okay, in this, you guys went around a super long way.
Narrowly windy road.
I
Never
think,
again. That's like when you
I don't know,
decide.
I just feel like y'all did a lot of steps on that.
It's like when you're going to Beckley and you think, hey, let's go across Little Bolt from Oceana, instead of you just going across 99.
So we're trying to find the force of friction, right?
We got
Yeah.
Okay, so
Let's
in
go to
this,
Logan
we need to
Hall.
find
Let's
the
do
net
Logan.
force in the X direction. Well, the net force in the X direction is equal to mass times acceleration. I have the mass, I have the acceleration of it, so the net force is just equal to 5 kilograms times 6.0 meters per second squared.
Equals 30.
Sorry, somebody text me. So 30 newtons.
No, it's okay. We know you had to go to the calculator real quick. Oh, he's double checking his answers.
But my wife just texted me, she's gonna save money.
Good job. Good job, Mary.
Yeah. Just for the guys in the room, if you're ever watching this video, if a woman's sitting on her phone, let me tell you what she's doing. It's called browsing.
Jessica Kinsey has been
So what
signed
we
out.
say is shopping. We're gonna find something to buy.
Yeah, buddy. Spend
So-
your money.
She
In
looks
there.
like Crib.
What? What'd you say?
You're looking for a crib for the baby. A little
There
bassinet.
is no baby.
There will be.
We will
Watch.
speak
Whoa.
it into
We
existence.
will.
You keep speaking in facts. Go right ahead. All right. So in this is where we can really get down and get to
He
the
gets home in the
meat
morning.
of it.
Just wait on time.
There's a baby left on his porch still. It's like, nope, we gotta take it in now.
I just take a picture and be like, somebody left this on my porch.
Left this on my phone.
Return to sender.
Lost in
Put a stamp on its forehead.
All right, net force in x direction is equal to the force applied plus force of kinetic friction. I'm trying to find force
You
kinetic friction.
started.
I wrote it that way for 4 years
I swear.
of teaching,
And we.
let alone in college. And you guys have changed the way I read it.
I'm sorry.
It
I
really
told
was.
Mary about that, and Mary her mind went somewhere else. And then I explained it to her, and then she was like, "That's not what I thought." And then I asked her what she thought, and then she told me, and I went, "That's even worse."
It's
It probably
just
is what we thought.
Yeah.
Was what
Yeah.
Mary was
The
thinking.
FAP part, definitely. Next.
You still have.
Next step.
I thought you had a dentist appointment to go to.
I mean, if you let me go, I sure
All
will.
right, so in this is also equal. The force kinetic friction will be equal to the net force.
You just moved your hand so much. We didn't know like you were going.
Drop my next.
See, like every time you go to write, you go to like do it.
I'm
My,
thinking,
my mom does the same thing and it drives her crazy when I call her out on it.
which is it? I don't drive me crazy. I don't care. So 30 newtons.
Why do you do that? I just
What?
noticed.
It's like
You're
you're
like-
prepped to
you're like
write, and so
going,
like you move
you're
it
like-
and then move.
You're like going. Okay, let's write it. Like
30 newtons.
you're like hovering over.
Yeah.
You're hovering. He's hovering.
The pen's a little nervous.
So now 10 newtons.
Now, can it be 10?
No.
It can.
Okay.
It
If you
depends
have-
what you have labeled as positive and negative, and I will be checking to see what you have labeled as
Well,
positive and negative.
technically, what? Never mind. Your
I have
net-
my force applied being positive. If
Your-
this ends up being positive,
Just change it.
that better be negative.
net force.
They're in opposite directions. If you put that as positive, I'd probably take off half credit and say, these are acting in the same direction, so you have a greater force.
And that's
You
why.
took off half credit because I put it in weight instead of neutral.
I did not take off half. I should have took off half, but not.
You took out, hang on, what?
Cookies.
What is this?
Yes.
So with your net force, you technically won't have a specific direction for that, would you? Like net force in the X direction, net force in the Y direction, because it's acting both ways, so it can't be.
No,
either positive
actually
or
you
negative.
will. Like that net force is actually what's making the thing do what it's doing.
So it's pretty much like finding the overlap, kinda.
Yeah, the reason is like we're not dealing with the Y direction right now is because it's just sitting on the surface and it's not falling through the surface or jumping up. But what'll happen is
No,
like
it won't.
whenever we start putting things on ramps,
No, we're not.
then what you'll have to do is you'll have to look at the Y direction because then the normal force is perpendicular to the surface and you have the force of gravity goes directly straight down, so you have to break one of those into subcomponents because you'll have, like typically how I'll show you guys to do it is you'll have the force of gravity in the Y direction and the force of gravity in the X direction. So the force of gravity in the X direction is actually adding to either motion or prevention of motion.
In the X direction?
Yes.
Why wouldn't it be Y direction? If it's-
Because in the Y direction,
Oh.
it's keeping it pushed against and not falling through
Okay,
off.
so
But you get the normal force from the force of gravity in the Y direction when we're on the ramp.
in that case, if it is sitting on a ramp, so say it's like here, would force of gravity be technically this way, like straight, or if it's sitting here, would it be like that way?
No, other way.
Straight?
Yeah, it's gonna be straight down. The normal force is the other one, the second one you
Okay.
said. That is
Gravity.
perpendicular
Okay.
to the surface.
So gravity will always be straight up and down,
Yes,
but the other one is.
perpendicular to the surface.
Okay, that makes more sense.
Okay, and C, what is the coefficient of kinetic friction? So C,
Would that not just be, 10?
no.
Isn't a coefficient of
The issue too.
Yes, coefficient is a number, but it's not
So you
that
take-
number.
Kinetic friction is equal to, the coefficient plus
No,
times,
yeah,
is it the
Normal
net force?
Normal force.
not the net,
Normal.
normal force.
You got the hint right.
Okay, so in this, we're trying to find coefficient, so the coefficient of kinetic is equal to the force of kinetic friction divided by the normal force. So in this case, we know that our force of kinetic friction is negative 10. This is where you gotta get smart, okay? You gotta think here.
But, listen, we ain't getting there, so.
I know how this says negative 10, but think about it. The coefficient of friction, can it ever be negative?
No.
So I'm just going to make both numbers positive. So I just need the values from them. I need the magnitude. So I'm going to put 10 newtons.
So this is like taking absolute value.
In this case, yes, because
Okay.
I know this has to be positive. It's not going to be negative.
So coefficient of kinetic friction is absolute value of kinetic, or
You can look at it that way.
Yeah,
Is
but
the
I
answer to
would-
this problem 0.2039?
I don't know.
yeah.
Hold on.
Yes.
I got that right.
Yeah, we got that right
Yes.
yesterday.
Okay, so 5 kilograms times 9.81 meters per second squared. And this is why I say it. It's because a lot of y'all are going to want to put a negative sign here.
It don't matter.
Okay, whenever you figure it out, it doesn't really matter. I'm just taking it as positive. Why? Because I'm not so caught up on that normal force in the direction it's in right now as much as I just need the value. I need that magnitude.
So even if we did put negative, it'd still be right.
No.
As long as this is not negative.
What?
Like you could do this, Christy. You could do this. You could put that negative to stay with consistency. If I put a negative there, it'd work out. But if I don't put the negative there, I end up with that negative number. You need to catch it and say, this number can't be negative.
Okay.
And so you just
So
need to
they
make it
either both
positive.
have to be positive or both negative.
So that's unsure.
Yes, in the end, this number is going to be a positive number.
Okay.
Coefficient of frictions are positive numbers.
Okay.
So you do that, you get 0.2039.
That's with the negative or without?
That
That
actually would
is-
never be negative. Because it's like you take the absolute value for it.
If this makes you feel better, I'll stick a negative there so that you can see it. But it doesn't matter. Like even in the first case, like where I did it, there was a negative there. I just wrote the number down. Why did I write the number down? I know it has to be positive.
Okay.
It can't be negative.
Is-
Coefficient of friction is a value. It is not a vector, so it cannot have direction.
So, if hypothetically, if it was negative, wouldn't that technically mean it's like not wait? It's like lessening the friction, or whatever. Like instead of
It
pulling,
would change the direction of friction,
Like
which you
instead
can't do. Friction is always opposite of motion.
yeah. So like instead of pulling it this way, it would just kind of like counteract it.
It wouldn't pull it less, it would flip.
Okay.
Okay, questions?
This number.
No, it's bad at all.
Can we fix on just this?
I'm not done adding the stuff.
Yeah, we could do like 2 separate ones. We'll quiz on just this, and then how about just the
He's
farm?
not a math teacher, Thomas, unfortunately.
Miss Argle, that's how she does them.
That's awesome. Miss Albright's a great teacher. One day maybe I'll follow that example. Today I might. All right, number 72. I really like this question.
Of course.
I do. It's a beautiful question. This is like, I feel like I see this question and I feel inspired.
It's a beautiful question.
It's beautiful.
It's beautiful.
So in this, your family just had a new refrigerator delivered. The delivery man has left, and you realize that the refrigerator is not quite in the right position.
Oh,
I think it's about time for us to go.
Yeah.
So you plan to move it several centimeters. If the refrigerator has a mass of 88 kilograms, mass equals 88 kilograms.
What number is
The
it?
coefficient of kinetic friction between the bottom 72 of the refrigerator and the floor. So this is kinetic friction coefficient is equal to 0.13. And the static coefficient of friction between same surfaces is 0.21. So static is 0.21.
And that's also a coefficient, right?
Yes.
Okay.
How hard do you have to push horizontally to get the refrigerator to start moving? So question to you. How hard do you have to push horizontally to get the refrigerator to move?
couldn't take, sorry.
Hang on.
I'm gonna go with,
The
Negative 0.13.
Wait a minute.
no,
Wait a minute.
16 newtons.
hold on.
At least,
There's a key here.
at least about 5. At least 5. If
Okay,
not,
so you said how much force?
Yeah.
But first we have to figure out how far away.
0.34.
Okay, hang on. This is.
Is it 112 point
No.
something?
see, we haven't done the static friction yet, is the
No way.
thing.
Static friction.
Hey, hold on. Okay, everybody stop, because y'all trying to do something. I want to get you thinking in the right way. Let me get you to think the right way.
Yeah.
Here's the key. These two.
Yeah.
In these, realize something. The force of kinetic friction is equal to the kinetic friction coefficient and the normal force.
Right,
Okay.
so the
But there
force-
was a difference whenever we talk static friction.
it was,
So
shoot, what
static
was it?
friction's when you
Less than or equal to the static friction coefficient times normal force. And this is why these are keys. Whenever you're looking at this, what's kinetic friction? When
It's
does that
already-
operate?
It's already moving.
When it's
Kinetic friction is
moving.
And static friction would be like,
And when it's at rest.
yeah.
So at rest, not moving. Now here's the thing, and every one of y'all can do this if you want to. You can stand up right now and push.
The best.
It'd probably be best if somebody was sitting in the desk. Push gently on a desk. As soon as it starts moving,
I pushed gently.
it then starts moving and you feel you can apply less force. And it will still sustain movement. The reason behind this is, look, you will always see this. Your static friction is when something is not moving, it's at rest. Its number is always larger than kinetic. You have to overcome static friction in order for movement to take place. So if you're ever questioning, will it move? Is it going to move?
Yeah.
Or if I'm asking you how fast something is moving and you don't know if it's moving, the first step you need to check is it have a force greater than the static friction
Wait a
force.
second. Wait a second. Please tell me you called me. You said that. Is it have a force?
I was thinking.
Does.
So you have to look at that first. So for me to determine whether this is moving or not, does this mean anything to me at all?
No.
The coefficient of kinetic friction means nothing. I don't need it.
Trash.
I don't need this formula.
Oh, he's gonna
Trash.
put the perfect
I need this.
But that's hard.
Cause you need to know how fast you need to, or how much you need to push in order to get it to move.
Do what?
Okay.
No, he's
Mike,
trying
do
to
you
move.
have to do anything to this problem?
Yes. We have to do some calculations. But this is like, it's the thought process first. Okay, I want you thinking. Don't just try to jump in and start doing some calculations. If you're going to learn something in this class, learn to think first. Come up with a plan. And then whenever you start going down, that's when you get a plan, execute the plan. That's like when you see me work stuff. If I hit a problem that I haven't solved before and I'm having trouble with it, that's when I stop and I'll start looking at this thing to break it down and say, how is this thing going to move?
The answer for that 181.2888.
You're close. Greater than.
It's
Okay.
equal
The
to.
force applied
equal to
cannot
the-
equal. It has to be greater than. Because if you are applying a force of 181.2888 newtons, what happens? You haven't overcome it.
So you just have
So
to.
you're at a standstill. But as soon as you overcome it, as soon as I go 0.28889, I've overcome that force.
Or,
Help
us.
Oh! I'll see y'all tomorrow when we finish moving the refrigerator.